This video is for Lesson 3, Probability of Compound Events. Be sure to turn in your Lesson 2 worksheet, which is also a quiz, and make sure you have your probability packet, a pen, a pencil, and a highlighter ready to go. Probability of compound events. Let's talk about the word compound. Compound is outside of math. If you gave me an example of compound word, could be bookshelf. It simply means that we could take two words and separate it right here and get two individual words. I can have a shelf, I can have a book, and if you put the book on the shelf, we have a bookshelf. Well, today that's what's going to be happening in our probability. We're not going to just have one thing, we're actually going to be putting things together. So Josh has 3 clean shirts that happen to be red, blue, and green, and 2 pairs of pants, tan and black. And he randomly selects one shirt to wear, and he randomly selects a pair of pants to wear. What is the probability of Josh choosing black pants and a green shirt? So a lot of kids will look at me with kind of blank stares at this point. What do I do? Well, in this case, when events become more complicated, calculating probability can be confusing. So we're going to learn how to use diagrams like charts, organized lists, and tree diagrams to make things easier for us. So this is an example of a tree diagram, and it looks a lot like the branches of a tree. So Josh has these 2 pairs of pants, tan and black. So we split it off and make 2 branches. Oops. And then we could label that he has 3 shirts, and so he could choose a pair of tan pants with the red shirt. He could wear tan pants with the green shirt, or tan pants with the blue shirt. He could also have worn the black pants with the red shirt, the green shirt, or the blue shirt. So let's list out all the possible combinations. We could have red with tan. We could do green with tan. We could have worn blue with tan. We could have also done red with black, and I'm going to write BL to keep it separate from the B for blue. Green with black pants, and I could have also worn the blue shirt with the black pants. So all in all, there was 1, 2, 3, 4, 5, 6 different outfit combinations. And since there aren't any repeats, they all had the same equal chances of being selected. So let's look at this. What is the chances that Josh would select an outfit that had a blue shirt involved? Well, we could have, and there was one other thing on the diagram. We always draw an O for outcome at the bottom. So we could count the outcomes, or I could list out all the outcomes. So there was 1, 2, 3, 4, 5, 6 outcomes. So if we look for the ones that have a blue shirt, this one would count. We could have a blue shirt with tan pants, but I could also have black pants with a blue shirt. So it's 2 out of 6, which can simplify to 1/3, which I know is 0.33, or 33%. So what is the probability of him choosing a blue shirt with the tan pants? There's a blue shirt with tan pants here, but over here the blue shirt went with black pants, so it won't count. So it's only a 1 in 6 chance, or 0.17%. And what are his chances of getting tan pants in the outfit? Well, he could wear red with tan, green with tan, or blue with tan. So that's 3 out of 6, or 1/2, which is 50%, or 0.5. So what was his chances of getting a shirt and a pair of pants that were not red? Well, I have red with tan would not work, but green with tan works, blue with tan, so that's 2 so far. I could not have the red and black pants, but I could have the green with black and the blue with black. So that would be 4 out of 6, or 2/3, which is 67%, the 67 hundredths, or 67%. One last question they want. What was your chance of getting black pants and a shirt that was not red? So none of these options on this side work because they are all with tan. However, over here, the red and black would not work, but I could have green and black or the blue and black. So that would be 2 out of 6, or 1/3, the 33 hundredths, or 33%. And remember, I'm getting these fractions into decimals quick because I've just memorized them. They're familiar to me. Otherwise, take the top number divided by the bottom on your calculator and you can get your decimal quickly. So let's draw one together. So we have for after school, you can get a snack, and you get a beverage and a snack. Your beverage choices are milk, water, or juice box. And your choices of a snack are cookies, pretzels, and grapes. So to make a tree diagram, I start off with those beverages. I have 3 beverages, so I need 3 branches. So make sure you open them wide so that you have plenty of room to put your labels. So I could have milk, I could get water, or juice. And with each of those drink options, I can make a choice between the 3 snacks. I could get cookies, pretzels, or grapes with milk. I could also choose water and get cookies, pretzels, or grapes. And I could have also chosen the juice box and chosen cookies, pretzels, or grapes. And our last item is to draw our O's for outcomes at the end. So we had 3 beverages and 3 snack options. So there's a grand total of 9 outcomes in this tree diagram. So what's the probability of getting milk with pretzels? So I go over here to the branch that has milk, and there is 1 outcome that is pretzels and milk, because here the pretzels with the water, we can't count it, and we can't use the pretzels with the juice. So it's a 1 out of 9 situation. And if we take 1 divided by 9, we get 0.111 repeating, so it's 11%. So what's our probability then of getting grapes? Well, I could get milk with grapes, so this outcome comes. I could choose water with grapes, and I could also get juice with grapes. So that's 3 out of 9, or 1/3, which I know then is 33%, or 0.33. So let's try this coin toss game. We're going to flip a coin, and if I flip a coin, I can get 2 outcomes. I can either get heads or tails. Now with this game, it says that if you get heads, you get to toss the coin a second time. So if I get heads, I can flip it again and get heads or tails. If you get tails, you lose. So that means I get to stop right here. On your second toss, if you get heads again, you win. Let's make a tree diagram to show all the possible outcomes. So what's the probability of winning the coin toss game? Well, heads only happens one time out of, and it's not going to be out of 3, even though I have 3 outcomes. So you have to remember, if we put our fractions on there, our chance of getting heads or tails is 1 out of 2. And our chance of getting heads on the second flip would also be 1 out of 2. And 1 out of 2 times 1 out of 2 is equal to 1/4. So this end fraction is 1 out of 4 options. Our chances of losing on the second flip is also a 1 in 2 chance. So 1/2 of 1/2 is 1/4. So over here, though, because I don't get to flip a second time, this is equal to 1/2, or 2/4. So the probability of winning the toss game is only a 1 in 4 chance, or 25%. The probability of losing the coin toss game, then, I could get heads, tails, and I could get the tails side, and because this is actually worth 2/4, there's 2 stars over here. So it's a 3/4 chance of losing. So is this a fair game? No. It is not fair because you have a 75% chance of losing. Remember, if it's a fair game, it would be 50-50, an equal chance to win and equal chance to lose. And since you have much higher chances of losing, it is not fair. So if tree diagrams aren't your thing, you can also make organized lists. Here we have members of a hiking club being served a breakfast bag, kind of like a sack lunch. It's a sack breakfast whenever they have a Saturday morning meeting. Members use a form at the right to place their orders. So the members get to choose between milk and water, plain or raisin bagels, an apple, a banana, or an orange. So we have 2 beverage options, 2 bagel options, and 3 fruit options. And we can find the total number of outcomes by simply multiplying them. 2 times 2 times 3 is 12. So we should have 12 options in the end. So we can start off, they've started the charts for us, that we can choose milk with a plain bagel and an apple. I can do milk with a plain bagel and a banana. So the next choice would be milk with that plain bagel and an orange. Now I'm going to continue with my milk, and instead of choosing a plain bagel, I'm going to choose the raisin bagel, and now I have to go through my fruit choices. I could get it with an apple. I could choose the milk and the raisin bagel with a banana, as well as the orange. So now I'm done with the milk. Now I need to work with my water choices. I can get water with a plain bagel and an apple, or a banana. I could also get water with plain bagel and an orange. Now switching over, I can keep the water and switch to raisin bagels, the apple, the banana, and the orange. So remember, this is one menu option. So how many different breakfast bags again? We counted up here, there's 12, because we can look at 1, 2, 3, 4, 5, 6 on this side with the milk, and an additional 6 over here with the water. So there are 12 different bags possible. So what is the probability, the theoretical probability of getting a bag with a milk and a bagel? Now it doesn't specify plain or raisin, so that means we get to count both. So this whole chart has milk with bagel options. So all 6 of those count. then none of these count because these are all with water. So it'd be 6 out of the 12, or 1/2. So it's 50%, or 0.5. So that was an organized list in a chart form. Now let's try another one where we have to create our own. We have a baseball team that has 4 pitchers and 3 catchers. And the coach wants to know how many pitcher-catcher combinations does the team have. Make an organized list or a chart to show all the possible outcomes. So if we start off, this one's a little tricky because we don't know the names of each individual pitcher and catcher. So we're going to have to use some abbreviations to help keep these straight. So I can start with pitcher number 1, and he could play with catcher number 1. Pitcher number 1 could also work with catcher number 2, as well as catcher number 3. Pitcher number 2 then also has the same options to play with catcher 1, catcher 2, and catcher 3. Pitcher number 3 has the same catcher options, and you can see a pattern developing. And don't forget, we also have pitcher number 4, and he gets to play with each of them as well. So in all, how many different combinations are there? 12. And we could have done that by taking 4 pitchers times the 3 catchers equals 12. Now we can turn this quickly from a list into a chart by simply drawing horizontal or vertical lines and horizontal lines. And now we have an organized chart. And again, we have 4 rows of 3, or 12. So now it's time for the practice assignment. Come get the Lesson 3 worksheet from me. Good luck, and if you have any questions, be sure to come and ask me.